Okay. One note about the comments. Comments in Julia are very powerful because there are two types of comment, single line and multi-line comments. Here, in particular, in this script here, you see that are used two comments, but that's because of the particular system that I'm using to auto-generate the documentations out of this file. But in general, you have a comment in Julia that just start with one hash, and this is a comment, okay? Or you have another systems that is given by hash and the equal sign, and then again equal and hash. And what is interesting is that in this way you can set comments in the middle of the line. So here, in this way, the comment, this one is the comment at the end of the line. But here you have a comment also in the middle of the line. And one very interesting thing with this form of multi-line comment is that we can nest the comment. So if I run all this one, this is all a comment. And in particular, look that this is nested within this bigger comment, and this is quite a rare flexibility to have about comments. So how do I organize my code? Well, you just run your code. You don't need to specify anything at the end of the line. What is the difference between this one and if I put a semicolon at the end? Okay, here the things are not printed here on the terminal, but you can see here that here whatever is in output is displayed. Here I am using the Julia plugin for Visual Studio Code, so it's displayed here. If I am using the terminal, it will be displayed in the terminal, but you can just see that the difference is that putting the semicolon, I do not output anything. So I can decide if I am not interested in visualizing the output of my command, I just put the semicolon. One important thing, and you may have different taste. So some languages like Python, indentation matter, and the blocks are defined by the level of indentation. In Julia, you can use indentation doesn't matter, so this run the same exactly things as if I ident the code. And indeed, what defines the ending of a block is the keyword end. This is the same for functions, for other kind of blocks, for modules, and so on. So you don't have curly brackets, you don't have indentation, you have the keyword end to close a block. This is a for loop. We'll see more in details for loops and also this strange syntax here. But what I want to say for now is just that the keyword used for closing a block is end. Here we said that indentation doesn't matter. However, what is space sometimes matter. As you can see here, you have the functions. This is we call the function println, print on a new line, and then between parentheses what we want to print, hello world. But a functions must be when you want to call a function, you must have the argument of the functions straight away. You cannot put a space like here, you will get an error. And I have to say that here the error is pretty informative, as it tells you in details that you need you cannot put a space between a function and its argument. So let's comment back again this one. Another characteristic of Julia that is particularly nice when you deal with equations that you have in your book or your handwriting is that you can use all the Unicode or a large number of Unicode to define your equations. For example, here I'm using statistics. And I define, okay, you already have the variance, but here I can use sigma as the Greek letter and the upper, the two in the upper positions, and define these new functions in this way, well, in the way of the variance. And I call it here. And I can also use the bar for the symbol of the average. So the way you do that is that you press the letter and you started the sigma. You can see here you get the list, everything, and you press enter and you have sigma. If you want to do, so you basically you use LaTeX. So you start with the slash, and then if you want to put something up, you use this symbol here and the 2, and you have an tab. You should be reliable. Why? Okay. 2, and you have it. And so you have it already. So in the French keyboard, you already have the 2 given by the keyboard, so you don't need it in this case. But for non-French keyboard, you can just use LaTeX syntax to get Greek letters or decorators or digits and characters on top or on the bottom of the line. So these are 2 separate Unicode characters, and but together they define a new variable that I can use as a placeholder for a function or indeed as a variable to hold some value. So after I have functions, I can call, I can define a function and I can call a functions. Something again very powerful of Julia is that it allows very simple with these so-called dot notations to do what is called broadcasting. That is it, to apply the same functions, to call the same function to a set of a collection of objects instead of a scalar one. So here I have a vector with 3 elements, and I want to add a scalar. So vector plus scalar, if I don't have this dot, is not defined. It will give me an error. Will tell me I cannot add a scalar to a vector. But what I can do is I can broadcast this operation, and in this way this plus will operate individually on each element, and I will have my my addition to the vector. So but what is interesting is that I can define my own function. For example, here I am defining a function whose name is add2, and well, it add 2 to whatever is given as argument. So this works with a scalar. So add 2, 10, I will have 12. Guess what? So if I want to have it, if I instead of a scalar, I have a vector, here again I will have an error, the same error that I have here, because this is defined for a scalar, and instead of a scalar I'm giving it a vector. So what I can do is that I can use a dot when I call the function. My user defined the functions, and use a vector, and automatically the functions will be applied to each element of the array. So in this case, it's very compact notations. I don't need to use maps. I don't need to use for loops and so on. Just add a dot, and the functions, even user-defined functions, like in this case, can be applied to arrays. Now with arrays, of course, there is this very important questions of which should be the base of the array, which should be the first element, should be 0 or should be 1. Now, if you take C, Java, Python, they use 0, but if you take MATLAB, R, Fortran, they use 1. So I think that they try to go, when they designed Julia, they proposed someone to propose 0.5, but this has not been accepted. And I'm kidding, of course. So they had to choose something. Each one has some, using the 0 or 1 as a base. Each one has some advantage for some algorithm, and it becomes things a little bit more tricky with other algorithms. At the end, they choose the 0. Sorry, they choose the 1. I am more used with 0, but at the end it's not such a big deal if it's 0, 1. Just you have to know that the first element here of the vector is the first element, here is the second, and here is the third one. So when we call it through bracket here A1, we are actually getting the first element of the array.